Okay, I made a little update to my simulation of the dumbbell curl exercise with the biceps muscle that I was running in class the other day to show the short moment arm case and the long moment arm case side by side here, so that hopefully you can see the distinctions and the differences in performance a little bit more clearly. Okay. So notice here we have two elbow joints, and they're both holding. You can't really see it, but they're both holding a little green 1 pound dumbbell out there at the hand. And this one on the left has a short moment arm. That's this little blue distance here. And it's short because this muscle is routed very close to the center of that joint. Okay? Then on the right here, we have a muscle that's routed much further from the center of that joint and then has a much longer moment arm. Okay? Now, I want you to observe what happens here when I do a simulation of the dumbbell curl exercise with these two systems here. And pay close attention here to how long the muscles are when they start, and then how much they shorten while the elbow is going through this full range of motion here for the flexion exercise. So here we go. So both did the same range of motion in the same amount of time, but notice how much shorter this muscle with the big long moment arm ended up than this one here with the relatively short moment arm. Okay? By having the short moment arm and routing my muscle very close to the center of the joint, that means that when I flex that joint, even though I go through a big range of joint motion, I don't really shorten my muscle very much. Okay, so that's the benefit of a short moment arm there. You can do big ranges of joint motion without shortening the muscle very much. If you're doing something fast, then that means you can do fast joint motions without the muscle necessarily having to contract fast or to shorten fast. With the long moment arm here, notice how much this muscle had to shorten. It's much shorter than this one on the left with the short moment arm. With the long moment arm, I do a big range of motion, and I need a big shortening of my muscle along with that. If I do a fast motion, then I need a fast shortening, a fast contraction of that muscle. And that's reflected here in these differences in the data that was spit out as kind of a summary of the simulation here. The max shortening velocity of the muscle fibers was about 3 times faster with the long moment arm. That puts me at a place on my force velocity curve with that faster shortening velocity where I can't really produce a lot of force, and that's reflected here in the large difference in maximum muscle forces these two muscles are able to develop. Because the smaller force here gets multiplied by a much longer moment arm, it didn't end up having a huge difference on the torque that those muscles developed at the joint, and that's reflected in the fact that they were both able to produce enough torque to complete the movement here. But the one with the shorter moment arm was able to develop a lot more power with that biceps muscle, and from that was able to move the joint and complete the motion a lot quicker, a lot faster velocity. Okay, about 800 degrees per second max speed there with the short moment arm versus a little under 600 degrees per second max velocity with the longer moment arm. Okay. So if your goal is speed, basically, if you're trying to move no weight or move a very light weight as fast as possible, then generally speaking, a short moment arm will be beneficial for that compared to a long moment arm. And again, why? Because a short moment arm that wraps your muscle very close to the center of the joint means the muscle won't have to shorten very fast, even if the joint is moving fast. So you can do fast joint motions while still keeping your muscle fibers at slow places on the force velocity curve where you can get a lot of force, a lot of power, a lot of joint velocity, even with a slow muscle fiber velocity. Okay, so that's if we care about speed. What if we just care about sheer strength? What if we just want to lift the heavier weight possible? Well, let's demonstrate that effect and that difference by just kind of slowly ramping the weight up here. Okay, so we saw when we did a 1 pound lift that we got a heck of a lot more power and a heck of a lot more force out of our muscle with the small moment arm. Okay? Let's up this to something a little bit more substantial, like 15 pounds. And simulate that. Okay, then my differences in terms of my joint level performance, in terms of the speed, have largely been washed out. They both did the movement at about the same maximum speed. We still got less force with the long moment arm versus the short moment arm. Why? Well, we still have this force velocity effect. We're still shortening the fibers much more quickly with the long moment arm versus the short moment arm. But the disparity here is quite a bit smaller. We're not doing 8 times as much force with the short moment arm. We're doing more like 2 times as much force. again, that force is getting multiplied by this much longer moment arm in the long moment arm case, which is resulting in a little bit more torque here at the elbow with the long moment arm overall than with the short moment arm. Okay. So it looks like we're kind of mitigating our advantage here with the short moment arm by lifting a heavier weight here. Now let's go up to 25 pounds. And now on the left, we're struggling a little bit. And we're still getting more force with the shorter moment arm, but we're getting quite a bit more torque out of that force from this longer moment arm with the longer moment arm case. Now we're getting quite a bit more power with the longer moment arm. Still a faster shortening velocity, but it's not hurting us so much in terms of the actual velocity of the joint here. Now let's crank it up to a big weight, 50 pounds. And there it's so heavy that I can only just simply hold it statically there with my short moment arm, but my long moment arm is able to still lift the weight. And let's go up to 70 pounds. And there gravity's winning out over my short moment arm case, but my long moment arm case is still able to lift the weight. Okay. Now here they're producing about the same amount of force. We're still having a small force velocity effect. We'll always have a force velocity effect anytime there's a non-zero velocity, and these are still moving at non-zero velocities. But my longer moment arm case was able to produce enough joint level strength, produce enough torque there to actually lift that 70-pound weight, where with the short moment arm case, even though it's producing a very large force, it gets multiplied by a very small moment arm, and it's not enough to overcome that gravitational moment. That's why you see the weight moving down instead of moving upward. Okay, so hopefully these differences are a little bit more clear by seeing these things side by side. Force velocity is always going to hurt us when we have a long moment arm, but it doesn't really hurt us on slow movements because we're going to be at places where we can produce a lot of force when it's a slow movement, and that force is going to get multiplied by a long moment arm, and you're going to get a lot of torque at the joint. You can lift heavy weights with that. If you don't care about the weight, if you're okay with a light weight, you just want to move it fast, then it's fast movement, force velocity has a big effect, and in that case, you want a short moment arm so that you can produce a lot of force with your muscle fibers operating at slow speeds, even though the joint is moving at a fast speed. It's possible with short moment arms, not so possible with long moment arms.